Sine. So the S, sine stands for opposite over hypotenuse. Cosine, the big C. Cosine stands for adjacent over hypotenuse. Tangent is opposite over adjacent. So take a second and copy that down, SOHCAHTOA. There used to be a bunch of weird songs and things that you would have to remember because they didn't give you the formulas. Now they give you the formula. So it says express each trigonomic ratio as a fraction. So if I say I want to find the sine of z, the cosine of z, and the tangent of z, we're all talking about angle z. So in your picture, let's put theta. Remember, theta is like a little circle with a squiggle. We kind of talked about that on Wednesday, I think. That's our little theta. That's our reference point. So pretend like I'm literally standing right here. Sine uses two things. It uses opposite over hypotenuse. So if I'm theta and I'm literally standing right here, what would be considered opposite of z? Would it be 35, 28, or 21? 21. So this is opposite. Okay, so I'm going to put an O there. If I'm literally standing on Z, what would be considered the hypotenuse? 35, because remember the hypotenuse is always technically the longest side. It's always the diagonal. So this is H. And then adjacent is going to be 28. It's technically right next to me. So is the hypotenuse, but the hypotenuse is longer than the adjacent side. So I'm going to put an A. So what would be the fraction for sine if I have to use opposite over hypotenuse? 21 over 35, because I'm opposite over hypotenuse. If I'm standing at Z and needing the cosine, what would be the fraction? I need 28 over 35. And then what would be the last one? Perfect. 21 over 28. So this is what we did last week, and then we would like actually solve problems with it. That's a little refresher. The new thing is angles of elevation and depression. So it's making a right triangle out of a word problem. So I want you to take a second. We're going to look at these two pictures. We have angle of elevation over here. Notice where my person is standing. Notice kind of like what I'm looking at. I have line of sight, angle of elevation, horizontal. Horizontal just means going straight across. I have an angle of depression. Now my person is over here. He's on top of a cliff. Okay. He's about to cliff jump. Okay. He's looking at a boat. I still have my horizontal, which is like my eyesight kind of thing, angle of depression, and a line of sight. So I want you to take a second based on these two pictures. And I want you to make like a little observation. So take a second and write just like a sentence, and it says, using the two photos above, use your own words to explain the difference between an angle of elevation and an angle of depression. So just jot down a little sentence about what you think the difference is about an angle of elevation and an angle of depression. So just a little sentence or two. Don't overthink it, but whatever you think makes the two different from each other. We're going to reflect that. We're going to do word problems. I want you to make that hypothesis because we're in science class today. I feel like you can see the sparkboard better when the windows are closed. Okay, so for our pictures, we're always going to have a person standing in them. We're going to go back to this later because we're going to edit it later. But we always have like a little person. So that's kind of like your reference point. Wherever you're standing at is basically going to be where your theta is at. Okay. So it says for the bottom ones, it says draw a picture of each situation. Use a trigonomic ratio to solve for the unknown. Round to the nearest tenth if needed. So for the first one, we're going to have to draw a picture for these because it's going to help your eyeballs understand what's happening. It says an angle of elevation from a yacht to the top of a cliff is 18 degrees. If the yacht is 300 feet, and it says foot, but it means to say feet, from the base of the cliff, determine the height of the cliff. So we're going to have to draw a couple things. What's one thing we're going to have to draw? A yacht. Okay, so let's draw a little boat. That's my boat. It's cute. Here's my boat. Okay. There's my sail. It says it's an angle of elevation. So based on what you think from these two photos above, does an angle of elevation, does that mean I'm looking up or I'm looking down? I'm looking up. So I'm technically standing on my little boat. This is me standing on my boat. I'm on a boat. Okay. I have an angle of elevation from a yacht to the top of a cliff that's 18 degrees. If the yacht's 300 feet from the base of the cliff, determine the height of the cliff. So I should also draw a cliff. So over here, here's my cliff. Okay. And here's the ocean because we're in the ocean. All of these pictures are technically creating a right triangle. So whatever you draw, it should be forming a right triangle. Where is this person looking at? Is he looking straight across? Or is he looking at the top of the cliff? If it's an angle of elevation, the top. So his eyesight is technically going straight up to this top of the cliff. And then this is what's forming basically the right triangle that we're going to use. Okay, so we have our right triangle. So it says the angle of elevation from the yacht to the top of the cliff is 18 degrees. So 18 degrees is going to be right here because 18 degrees is going up to the top of the cliff. It says if the yacht is 300 feet from the base of the cliff, determine the height of the cliff. So I need to think about where I should put the 300. Should the 300 be the hypotenuse? Should it be the adjacent to 18? Or should it be the height of the cliff over here, the opposite? Where do you think I'm going to put the 300 if it says 300 feet from the base of the cliff? Not the opposite. Because the opposite would be over here. The A. So 300 is going to go here because it's 300 feet from the base. The base means the bottom of the cliff. So from here, from me to the bottom of the cliff is 300 feet. I need to determine the height of the cliff. So is that going to be the hypotenuse or would that be the opposite? The opposite. So this is where I'm going to put my X. So I have an opposite and I have an adjacent. So what trigonometric ratio will I have to use? Sine, cosine, or tangent to solve for X? Tangent. So I'm going to have to use tangent of 18. The math is still the same as last week. It's just now word problems. And tangent is technically O over A. So is my fraction going to be X over 300 or 300 over X? X over 300. So the math is still the same. So now just like last week, I'm going to put tangent over 1. And then I'm going to cross multiply. So cross multiplication. I have 300 times tangent of 18 equals X times 1, which is just X. So this is nice because X is by itself, so I don't have to divide or anything. I'm just in a calculator going to multiply these. So I have 300 multiply, oh crap, clear my calculator first. 300 times 18 tangent. And then press equals. So that is 97.47, and we're rounding to the nearest tenth. So I'm going to say 97.5 because the 7 rounds it up. So X is about 97.5. So what that means is that the cliff is technically 97.5 feet tall. Come on in. There you go.
There you go. And then I left my phone all the way back in the gym. I had to go back to the gym to get the phone.
Okay. Okay. So the next one, same thing. We're going to have to draw a little picture, just a little sketch. So take a second, read number 2, maybe underline your important information. Beautiful little picture. Yes, what's up? The pilot of a rescue helicopter spots a swimmer in distress. So you're in the helicopter. And that's why it's an angle of depression this time, because you're up high and you're looking low. So you're seeing the person drowning and you're like, oh, I should probably save them. Okay. Or maybe not. We're just going to fly by them. Okay. So it says the pilot of a rescue helicopter spots a lost swimmer in distress at a depression angle of 12 degrees. If the helicopter has an altitude of 100 meters, determine the distance from the helicopter to the swimmer. Okay. So you're in a helicopter. So now we got to draw a helicopter. So here I am. Okay. I'm not just floating in the sky. I'm in a helicopter. This is my helicopter. Okay. Don't judge my helicopter skills. There we go. There I am. Okay. There's my helicopter. There is somebody drowning off into the distance. Okay. Because you're not looking straight down. You see somebody over here. They're like literally dying. They're drowning. Okay. And they're yelling for help. Okay. So there's my little picture. It says the pilot spots a lost swimmer. It's an angle of depression of 12 degrees. So with your angle of depression, hopefully you noticed that an angle of depression, you are looking down. You're looking down at the ship. Now with your angle of depression, that actually means your angle of depression is right here. So this is my angle of depression. Because these are technically forming parallel lines, I have two lines right here and right here, cut by a transversal, which is the stuff from before Christmas break. You can actually take your angle of depression and you can move it into another place because alternate interior angles are congruent. So if this is 12 degrees, this would also be 12 degrees here. So 12 degrees is not going to be, because I'm forming a right triangle. So if I form a right triangle with my picture, because all of these pictures, once again, are making 90-degree angle triangles. 12 degrees is not going to go right here. Bless you. 12 degrees is actually going to go right here. Heck yeah, you gotta draw the little people. That's the whole point. Isn't it fun? It's like art class today. You guys like to doodle on your papers. Here, take full advantage of the doodling today. So your line of sight is going straight forward. So 12 degrees, your angle of depression, you're looking down from your eyes to right there is technically right here. So you can move your 12 degrees over here because of alternate interior angles. So if you always want to remember it as technically the bottom of the triangle, that's that gets the angle, that's totally fine too. Now we have to decide where we're putting our X and where we are putting the, yeah, it's fine. The 100 meters. So it says if the helicopter has an altitude of 100 meters, where should the 100 go? Should it go on the side or should it go on the bottom or should it be the hypotenuse of the triangle? The side. So the helicopter's at altitude of 100 meters. So 100 goes here because that means it's from the bottom, from sea level straight up is 100 meters. I need to determine the distance from the helicopter to the swimmer. So where is X going? Yeah. Is it the hypotenuse? Yes, it is the hypotenuse. So I'm going to put X here. And once again, I still have my right triangle. I have from 12 degrees inside the triangle, I have the opposite and I have the hypotenuse. So is that sine, cosine, or tangent that I have to use? If I have the opposite and I have the hypotenuse. Sine. I'm going to say sine of 12. And then it's opposite, so it's 100 over the hypotenuse, which is X. So the math is exactly the same as last week. It's just now you have to create your problem. So I'm going to put it over 1 and cross multiply. So take a second, put it over 1, cross multiply. Last time I had to multiply. What am I going to have to do this time? Divide, because I have to get x by itself. So I'm going to divide by sine of 12, divide by sine of 12. So in your calculator, you're doing 100 divided by 12 sine, and then you have to press enter. 12 sine. So you should get x is about, since it's 480.97, that 7's going to round the 9 up, which is then going to round the whole number up to around 481 feet. Or meters, sorry, not feet, meters. But 481 is the answer. So 481 is technically the hypotenuse. So from you to him directly. So flip your paper, try number 3. Maybe start underlining your important information. Okay, so a ladder rests against a wall. The base of the ladder is 4 feet from the wall. If the angle of depression from the ground is 52 degrees, determine the length of the ladder. So you should hopefully have a wall. Maybe, I don't know, maybe you have a house. You don't have to have a whole house, but you have a wall. I'm putting up Christmas lights, so I'm going to make my little thing like, here's my ladder. Okay. This is forming a 90-degree angle. It's got my little triangle here. Hopefully you started drawing a little picture. Something along those lines. You should have a ladder up against the wall and a 90-degree angle. We have to figure out where we're putting the things. So it says the base of the ladder is 4 feet from the wall. So is 4 going to be the hypotenuse? Is it going to be the bottom of the triangle, or is it going to be the height of the wall? Where should I put my 4? The bottom, the side, hypotenuse. Not the side, because it says the base of the ladder, the bottom, because the base of anything means the bottom of the ladder is 4 feet from the wall. So that means from here to here is 4 feet. So I'm going to put a 4 there. The angle of elevation, so that means it's looking up. The angle of elevation from the ground is 52 degrees. Automatically, every single time, wherever your right triangle is at, the angle that you're using is always going to be that bottom angle. So 52 degrees is going to go here, whether it be an angle of depression or elevation, because if you have an angle of depression, you're just going to move it to the bottom anyways, because it's starting up high, it's going to the bottom. So it's always going to be this bottom angle. I have to determine the length of the ladder. So am I putting X on the wall of the house, or am I putting it on the ladder? If I want to know the length of the ladder. On the ladder, because that would make sense, because I'm trying to find the ladder. So based on what I have in reference to 52 degrees is right here. I have technically this right next to me, and I have X over here. I have adjacent and I have hypotenuse. So if I'm using adjacent and hypotenuse, you're going to have to use cosine. Cosine is adjacent divided by hypotenuse. So take a second, set up your proportion. Cosine of 52 degrees equals, and you need your fraction. Adjacent divided by hypotenuse. But directly hypotenuse is global. I'm going to put it over 1, and I'm going to cross multiply. So I have x times cosine of 52 equals 4. I have to get x by itself, so I'm going to divide to both sides. So x should be around, since it's 6.49, that 9's going to round the 4 up to a 5, so 6.5. How do we feel? Do we feel like okay? Do we feel lost? We're lost. We're completely lost. Try to read number 4. We'll do this last one together. Try to read number 4. Underline your important information. All these things are going to have a right symbol somewhere in them. Yep. This was like last week, but now we have a word problem, so we have to make a picture. But now you're lost again. It's okay. You're not. Okay, so an observer in a lighthouse is 55 meters high. So draw a little lighthouse. He's on top of the lighthouse. Yeah, because I'm not a lighthouse.
It's a lighthouse, that little long circling thing.
Yeah, it's like a cylinder kind of looking thing.
Yeah.
And then, so it's 55 meters high. That's what we drive over there so that we know that's how tall it is. Yep. And then besides the ship, I was saying it just snitch.
But I'm not sure. It's them so actually. Why is the shit? I have always other. I'm not like it's probably like 2000. You can put on my video, but I'm not trying to.
Perfect. He slides the ship to draw a line connecting it to the ship. That's my heat. It's actually going down.
Good.
It's 18 degrees. So technically 18. Well, it's degrees, so it's your so it's gonna go inside. So it keeps looking straight, 18 degrees technically here.
So,
But it's really moving here because it holds the interior. Okay, and then if the foot of the lighthouse is at sea level, how far is the ship from the base of the lighthouse?
it can't be like, oh my God.
Okay, from this here. So connect all the make a right triangle. And then put your X out there. So 18 is here, you have the opposite. And you have adjacent. So which one uses the opposite?
Should you sign? No, it's hearing yourself. Is hearing?
Yep.
As long as I don't say it.
I know, you guys are all like, what in the world? So here's my lighthouse, okay? I'm gonna draw a lighthouse. Here's. I don't know, don't they usually have like diagonals on them? There's my lighthouse, okay?
Oh, that's for the lighthouse.
I don't know, it's like a little light, and then I'm like, this is where I'm at, okay? Yeah, it's tangent. So there's my little lighthouse, okay? It's 55 meters high, so I'm gonna put 55 over here because it's 55 meters tall. I'm just standing in the sky. I spot a ship. Here's my ship. It's really like a sailboat, but whatever. There's my sailboat. I spot the sailboat in the distance. So that's why it's an angle of depression, because I'm looking down, okay? Because I'm higher than the other object. The angle of depression is 18 degrees. So you're forming a right triangle. I have my right triangle. Here it is. Here's my right angle. Okay. 18 degrees is technically from the eyesight going straight forward, looking down at the boat. But that doesn't help me technically. 18 degrees is always going to be the bottom angle of all of your triangles, or like the angle that they give you. The reason why is because of alternate interior angles. These are two sets of parallel lines cut by a transversal. So I have 18 degrees here and I have 18 degrees here. And then it says, if the foot of the lighthouse is at sea level, how far is the ship from the base of the lighthouse? So am I putting my X on the hypotenuse or am I putting it at the bottom? The bottom, because it's the base. I want to know the base, the distance from the base. So from 18 degrees, I have opposite. 55 is going to be opposite of 18. And I have this thing right here, which is adjacent. So which one uses opposite and adjacent? Tangent. So you're doing tangent, and you guys are good at solving them now. It's just drawing the picture and setting it up. Tangent of 18 degrees, technically. Opposite is 55 over adjacent, which is X. So you guys can solve the equation. So take a minute and solve it. I'm going to help you set up the last two problems. We're going to draw the pictures together, and then that way you only technically have those three like problems to solve, okay? So you need to finish this. It's not done. For number 5, it says a kite with a string of 75 feet is flown in a park with an angle of elevation of 45 degrees. Determine how high the kite is in the sky. When you're flying a kite, it's never flying directly above you unless the wind is like super crazy, okay? So when you're flying a kite, I'm going to draw a little picture. Here's my little kite. I'm standing off here, off into the distance. My kite is connected to my hand, right? So I'm forming a right triangle out of me flying a kite. The kite is barely ever literally straight above you. It'd just be weird, right? If it was literally like this. It's always like this. It's okay. We're not in art class, but so there's my little person flying a kite. I'm gonna form a right triangle by just going straight down and across. There's my 90 degrees. So we have to put the numbers in the right spot. So if the string is 75 feet, what part of the triangle would that be? Would that be the bottom of the triangle, the height of the triangle, or the hypotenuse of the triangle? The hypotenuse, because it's the string. I'm holding the string. So 75 can go here. That represents the hypotenuse. The angle of elevation is 45 degrees. So where's 45 degrees going? Is it going in this top angle or the bottom angle? The bottom. It's always the bottom. So 45 can go here. And then I need to determine how high the kite is in the sky. So am I trying to find the height of the triangle or the base of the triangle? The height, because I want to know how high it is in the sky. So if I have opposite over hypotenuse or opposite and hypotenuse, is that sine, cosine, or tangent? Sine. So for this one, you'll use sine. We're going to set up the last picture together, and you can go back and solve them. So number 6 says the shadow of a building is 30 meters long when the angle of elevation of the sun is 56 degrees. Determine the height of the building. So I have a building, so I'm going to draw a little building. That's my building. Where's the shadow going to be at? Where's your shadow at? It's on the floor. So here's my shadow. Okay, so that's my shadow, literally my shadow. I'm forming a right triangle. So I have my right triangle, here it is. It says the shadow of a building is 30 meters long. So is 30 meters going to be the height of the building, the base of the triangle, or the hypotenuse? The base, because it's the shadow. When the angle of elevation of the sun is 56 degrees, where's 56 degrees going to go? Where's all your angles going to go? In the bottom. Determine the height of the building. So am I trying to find the hypotenuse or am I trying to find the height? The height. So I'm going to put X over here. So if I have opposite and adjacent, is that sine, cosine, or tangent? Tangent. So you can go back and solve 4, 5, and 6 now that we kind of drew the pictures together. And then once you're done with the math, I want you to go back and do your reflection piece about your observation you made in the very first thing, which you can just write a little sentence for. Okay, so you have 3 problems you actually have to solve. I'll zoom out so you can see them all. So you have those 3.